Good morning, one and all present here. So, myself, I am Mohammed Ghassan, Assistant Professor in Information Technology in Erode Secondary Engineering College, Perundurai. So, today I am going to present the topic computer organization. In that computer organization, we discuss the inner topic is assembly level languages. So, come to this next slide. So, assembly level language or low level language, it is also a machine level language. So that means in high level language we know that C++, Java, Python programming, etc. Whereas in machine level language programming, it consists of binary numbers, that is zeros and ones. The inputs also zeros and ones, the output also zeros and ones. So Uh, so now the when the program executing the time, we giving the input as zeros and ones, the binary numbers. The binary numbers are the input values. For example, A is one input and B is one input. So we're going to represent uh, corresponding binary number for these two inputs. These two inputs are called variables. Here we called denoted as the operands. Okay, so the operands are nothing but it is the containers to store the data. We want to store the data into the computer memory. We need some memory spaces. So the memory spaces, we go for registers. So register is nothing but it is the segment of the memory. So each segment consists of some binary address. So the register r1 r0 field to up to how many of bits we want to implement in your program, we can implement. But here the we can use only register r0 to r7. So only 8-bit register having the base computer. So the first point is program counter. So the program counter means nothing but the program counter fetches the address of the next instructions. That is, the program counter starts at 0 or 1 at the first time execution of the program. If it is going to execute a first instruction, the program counter starts at 1. Then it is going to execute a second instruction or second line of your program or second line of the subroutine. The program counter will be incremented by 1 up to the end of the instruction. The program counter will be incremented by each time. The program counter consists of the flag registers. The flag registers denoted the address of the opcode fields. Okay, so these kind of usage are having in this program counter register. So then after each instruction is fetched, the program counter points to the next instruction in the sequence. When the computer restarts or is reset, the program counter normally refers to 0. After that, accumulator register. The accumulator register is nothing but, so it is one of the CPU register. So what is the necessary to need a accumulator register is, if you're going to add two variables or two numbers, the overflow or carry numbers we want to store into the another one memory location. That type of memory locations are called as temporary memory location. So these type of temporary memory locations are available in accumulator register only. So we want to store the temporary storage variables or data in the computer memory. We can make use of this accumulator register. Okay, then base register. The base register content is added to addressing field of the instruction to be obtained the effective address. A base register holds the base address and addressing field in the instructions gives displacement according to the base addresses. A particular register has to be selected from the register set according to the instructions. So here we know that program is known as a set of instructions. Likewise here, the instruction set is known as programs or subroutines. Okay, in machine level, we call the program as subroutines. So subroutines is nothing but subprograms or instructions, like that. So instructions contains some operations. So operations means nothing but basic arithmetic operations, since addition, subtraction, multiplication, division. So the operation consists of two operand values and one operator. Here a and b are the variable or operands. Okay, so the plus symbol, minus symbol, multiplication symbol, star, slash symbol, these are some operators. Okay, then the operation is addition operation. uh, if we want to adding two numbers, we can use um, some register memory spaces. So the base register content is added to the addressing field of instruction. To obtain the effective address, a base register holds a base address, and the addressing field of instructions gives displacement according to the base address. A particular register has to be selected from the register set according to the instruction. So the next key point is stack pointer. So what do you mean by stack pointer? The stack pointer is nothing but it is one of the data structure. The stack register is used to store the memory data into the memory. So the stack contains some memory spaces for allocating this stack using push and pop operations. If you want to insert a new element or insert a new operand value in the stack is by means of this push operation. Okay, or insert operation, or adding operation, or um, write operation, sorry, read operation, or takes place by using this stack push. Okay, so after that pop operation. So pop operation is need for deleting the element from the stack. If you want to deleting the element from the stack and remove the element from the stack, or else we going to write the output values from the memory to the output devices using this pop operation, we get the output values. Okay, so that is the usage. So the stack pointer is a small register that stores the memory address of last element added to the stack, or in some cases the first available address in the stack. A stack is a data structure or store device that follows last in first out, or else first in last out systems. Okay, so the consider a tumbler contains the coins. I going to insert a new coin in the tumbler, means the there will be some empty space. There will be some empty space in tumbler. Okay, then only you going to insert a new coin in tumbler. Likewise you want to Likewise, you're going to insert a new element in the stackers by means of empty spaces available in the stack registers. If you are going to pop the element from the stackers by means of uh, it wants to be fill it some elements from the stack. So the meaning is uh, the insert operation takes place in the empty stack. Okay, the deletion operation or pop operation done in the full stack. Okay, so the point is the full stack cannot be do the insert operation or pop operation. That is the error. Okay, error coding. Then the full stack, sorry, empty stack, we cannot do the pop operation. So this is also error. Top of the stack. So TOS is the top of the stack, the top element. The top element is the one which was recently added in the stack. The last added element in the top element of all the elements that are present in the stack. The top element stands out and is more significant as all the major operations on the stack are preferred at the top element. Okay, a stack is the abstract data types. So what do you mean by abstract data types? That is popularly based in most programming languages. It is named stack because it has the similar operations as real world stacks. For example, a pack of cards or a pile of plates. So you just imagine a pack of cards. A pack of cards contains them cards stored in the packets. Okay, so likewise the pile of plates, we store the plates at one by one. So we going to add a new card or add a new plate by means of the top of the stack or the top list only. Okay, if you want to remove the card or if you want to remove the plate, that is also takes place the top of the stack. Okay, then stack representation. A stack abstract data type allows all data operations at the end only. So at any given time, we can only access the top element of the stack. So the diagram shows that the operations of stack clearly. So stack is the last in first out or first in last out system. Okay, both are same. Here the two stacks are available. The push operations is performed in the empty stack at the top position of the stack. The pop operation is takes place at the full stack at the position is top of the stack. Okay, so this diagram will explain the clear meaning about the operations of stack. After that, so here the push is operation that insert elements into the stack. The following is an algorithm that describes the push operation in the simpler way. Pop. The pop data manipulation operation which removes the elements from the stack. The follow pseudocode describes the pop operation in a similar way. In a simpler way, instruction formats. So we're going to discuss the next topic. Next related topic is instruction formats. So first, what do you mean by instruction? So if you going to define a program or a routine or subroutine, it is nothing but it is sub set of instructions. So what is instruction? So instruction having some structure, right? So in this instruction have some opcode field and address field and also the mode field. Okay, these are the three basic elements of the instruction formats. In computer organization, instruction formats refer to the way of instructions are encoded and represented in machine language. There are several types of instruction formats. The first one is three address instruction format. The second one is two address instruction format. Then one address instruction format and zero address instruction format. The three address instructions, this has three address field to specify register or memory location. The program created are much short in size, but number of bits as per instruction increase. This instruction make creation of a program much easier, but it does not mean that program will run much faster because now instruction only contain more information, but each micro operation will be performed in one cycle only. To address instructions, these common commercial computers are used. These two address instruction can be specified in the instruction. Unlike earlier, In one address instruction, the result was stored in accumulator. Here, the result can be stored at the different locations, different memory locations, rather than just accumulators, but require but re- uh, but require more number of bit to represent address. This uses then after that one address instructions. This uses an impiled accumulator register for data manipulation. One operand is in the accumulator and the other is in the register memory or location or memory location. Okay, so the meaning is the operand field occupies the accumulator register or some other memory registers in the memory locations. Okay, so impiled means that the CPU already knows that one operand is in the accumulator, so there is no need to specify it. Zero address instruction. The zero address instruction, these instructions do not specify any operands or addresses. Instead, they operate on data stored in register or memory locations implicitly defined by the instruction. After that, three address instructions. These instructions specify three operands or addresses, uh, which may which may be memory locations or registers. The instructions operates on the content of the three operands, and the result may stored in the same different location. For example, the three address instruction might multiply the contents of two registers together and add the content of the third register, storing the result in fourth register. Each type of instruction format has its own advantages and disadvantages in terms of code size, execution time, and flexibility. Okay, so the meaning is each type of instruction format has its own advantages and disadvantages. Okay, according to this size of the coding and execution time and flexibility of the coding, likewise the modern computer architectures typically use a combination of these formats to provide a balance between simplicity and power. A computer performs a task based on the instruction provided. The instruction in the computer comprises groups called fields. The fields contain different information. As for computers, everything is in 0 and 1. So each field has different significance based on which a CPU decides what to perform. Operation field specifies the operation to be performed, like addition. Address field, which contains the location of an operand, that is a register or memory location. Mode field, which specifies how operand is to be found. Instruction is instruction is of a variable length depending upon the number of address it contains. Generally, CPU organization is of three types based on the number of address fields. The first one is single accumulator organization. The second one is general register organization. Then the third one is stack organization. In the first organization, the operation is done involving special register called accumulator. So accumulator register is nothing but it is the temporary register. Okay. So in second, multiple registers are used for the computational purpose. The third organization in the work on the stack basis operation, due to which it does not contain any address field. Only a single organization doesn't need to be applied. A blend of variables organizations is mostly what we see generally. Then we have one assembly language coding, going to find these expressions. So the expression, following expression is x is equal to a plus b star c plus d. Based on the number of address instructions are classified as, note that we will use x is equal to a plus b star c plus d expression to showcase. So first one is zero address instructions. So the zero address instructions, for example, you want to find the addition of two operands. Okay, two operand is two variables, um, like a comma b. Okay, or multiplication of two operands a star b. So the inputs are a and b. You want to put the input or data into the some memory spaces, that is stack. So in zero address instruction it consists of the stack memory only. So in this stack memory we add one element, that is a value of a into the stack. After that add another one element into the same stack. Okay, then only going to find the addition operation or product of these two operands. So that we use the push and pop operation. So push a is stands for the inserting a operand a value to the stack. Then push b is used to inserting a next operand value to the same stack. After that the operation is multiplication operation. So a star b, we find the a star b value into the some other memory location. After that that particular answer will be transferred to the stack. So this is the operation of the stack in zero address field. Okay, then expression x is equal to a plus b star c plus d. The first fixed x is equal to a b plus c d star c. Okay, see this. So this is nothing but all of you know about the data structure. In this data structure we are going to find the polish notation and reverse polish notation or postfix notation, whatever we want. Okay, in our program, in our subroutine, we going to use this kind of postfixed notation only. So the top is the top of the stack. Here one mistake is occurred. This is not a top, so this is the tos. Okay, so tos is the top of the stack. Then m of x. So m of x, we no need to read this as m of x, memory operand at address x. Okay, so the memory operand at address x is the some memory location. So the operand or a variable name is x, right? Then push operation. Okay, uh, instead of push and pop operation, we going to uh, calculating this zero address instruction field. Okay, the first one is push a. The push a is used to add the new element or add the new operand value into the stack. Okay, after that the content of a, so that is the value of a, operand a, will be transferred to the top of the stack. Okay, here this is not top, this is tos, right? Then push b. So the push b instruction is used to insert a operand value b into the top of the stack, right? After that the subroutine is add. Okay, the subroutine add is used to adding both elements or adding both operand field, that is a plus b, and the result may stored into the top of the stack. Okay, so that is the meaning. All of you see here. So adding this content of a with the content of b, then the result will be stored into the top of the stack. That is the meaning. So then push c. Push c is nothing but store the element of c, that is operand. Okay, the operand value into the top of the stack, right? So this instruction is refers to the push c. After that push d. Okay, the push D is nothing but it is push one element to the top of the stack. So here the D is the new operand field to be added or inserted. Okay, so the value of D will be added to the or will be transferred to the top of the stack. So that is the this micro operations. Okay, after that the next instruction, um, add top is equal to C plus D. Okay, so we give the subroutine as add. Okay, the micro operation is contains the content of C, operand C will be added with the content of operand D. That is the value of operands, both operands will be added together, and the result will be stored into the top of the stack. After that multiplication operation is performed. So the multiplication operation, top is equal to C plus D star A plus B. The two expressions are C plus D is one addition operation, A plus B is another one addition operation. So these two operations is multiplied together, and the answer will be transferred or stored to the top of the stack. So this is the instruction format, mul mul's usage. Okay, after that pop x. Okay, pop is nothing but it is the deletion operation or removing operation. So what we going to remove here is top of the stack value, right? The top of the stack value contains the calculated answer. The answer we going to transfer into the some variables. Okay, some variable like in this in this expression they given x. Okay, so memory operand at x. Okay, the top of the stack value will be transferred into the memory operand at x value. Okay, after that, so this is the, so far we discussed about the micro operations and the instruction formats. After that the subroutines. Okay, the instruction sets of the zero address instruction field. Okay, here there is no use of accumulator register, base register, index register, um, or address register like program counter or accumulator register. Okay, so we no need to use any one of register here. uh, Here we just use the stack memory and the stack registers. Okay, after that the advantages using stacks, they are simple and can be executed quickly since they do not require any operand fetching and addressing. They also take up less memory spaces. Okay, so you just imagine you going to add a value or store some value. So these are all keeps inside of the stack in the particular small memory spaces. So we can allocating the stack memories for less memory in paging or page table or page replacement technique. These are all are available in the stacks also, so that we need less memory only. After that disadvantages, uh, they can limited their functionality and do not allow for much flexibility in terms of addressing modes or operand types. Oh, it has some particular um, fixed memory only. Okay, so it contains only the opcode fields. Here we cannot add the, so here we cannot add the opcode field and address field and mode field separately. This is the difficult to follow this stack operation. Okay, whereas in one address instruction format, in this uses implied accumulator register. Okay, so accumulator register I already told that it is one of the CPU register. um, it is used for a temporary memory storage, temporary data storage. So that is data manipulation. One operand is in the accumulator and the another is the register or memory location. Impiled means that the CPU or the CPU already knows that one operand is in the accumulator, so there is no need to specify it. Expression x is equal to a plus b star c plus d, same. Then accumulator register, the memory of the memory location of t is the temporary register. So the purpose of temporary register is storing the overflows or carried out these kind of flow values or inputs or datas are just present in the temporary memory locations. So that is memory operand at t, at address t. Then the instruction formats are: first one is opcode field, the second one is operand or address operand, the third one is node field. The first one, opcode. So what do you mean by opcode is it is a short form of operation code, right? The opcode is nothing but it is a short form of operation code. After that, the operand. The operand is nothing but it is the variables, okay, or alphabets a b x y r1 r2, these kind of variables or registers. These are the operands of the program, operands of your subroutines. Okay, then mode field. The mode field is nothing but it is going to explain to them what the program going to do, the what the instruction going to perform. So these kind of instructions are present in the mode field only. Okay, then see the another one see the another one micro program, or see the subroutine. Okay, see the subroutine of one address instructions, uh, load a. Okay, so load operation. So what do you mean by load operation? Load a is nothing but it is going to allocating a accumulator register value, right? It is going to allocate a memory location in the accumulator register. Okay, if you give load a, the input a is stored into the some accumulator register. That is the meaning. Um, you give load in the microprocessor, the processor said to be the microcontroller to ready some memory spaces in the accumulator register for future purpose of memory storage. Okay, right, like a. Okay, add b. Okay, this add b is nothing but we going to add two operands. Okay, the first operand is stored in accumulator register, the second operand is in b register, operand b. Okay, so the micro programs are: the value of accumulator, the content of accumulator will be added with the memory operand at address b, then the answer will be transferred to the same accumulator register. Then store t, the memory of uh, the final answer from the accumulator register will be transferred to the memory operand at temporary register t. Then load c. Okay, so what is the meaning of this load c? Accumulator register is equal to memory operand at address c. The meaning is, the meaning of this micro operation is the content of c, operand c will be transferred to the accumulator register. Add d. Okay, so add d consists of two operands to be add. Okay, the first one is contains in accumulator register, then the second one d in memory register. So accumulator register is added with the memory operand at d register. Okay, the accumulator register will be added with memory operand at address d, and the result will be stored into the accumulator register. Okay, then multi. The multi is nothing but the memory operand at address t. Okay, that is content of the t uh, will be multiplied with accumulator register value, the content of accumulator register. Okay, the final answer will be moved to the same accumulator register. So this is the meaning. Then store x. So the what is the meaning of this store instruction? Store x is nothing but the accumulator register value will be transferred to the memory operand at address x. So that is the meaning of store x value. After that, the main advantages and disadvantages of this one address instructions. Advantages: they allow for wide range addressing modes, making from more flexible than zero address instructions. They also require less memory space than two or three address instructions. The disadvantages: they can slower to execute since they require operand fetching and addressing. The address instructions, this common in commercial computers here. Two addresses can be specified in the instruction. Unlike earlier, in one address instruction, the result was stored in the accumulator. Here, the result can be stored at different locations rather than the accumulators, but require more number of a bit represent address. So take the same expression here, r1 and r2 are the registers. Okay, so m is the memory location. uh, we can add any register location or temporary storage location or some opcode field location into the memory. So the instruction formats are: the first one is opcode, that is operation code field. The second one is register field. In this register field, there are two kind of registers is available. um, the first one is source register or source address. So we can use either this r1 or r2 into the source address. The another one address is might to be a destination address. Then the mode field, the last one is mode field. The mode field is nothing but what we going to do in this opcode or this instruction. So that is called as mode field. Then the subroutines are move r1 comma a. Okay, here there are two kind of register is used in this micro program. Okay, so r1 comma a, so micro operation at memory operand at address a will be transferred to the register r1. So that mean the content of value of the content of a will be transferred to the register r1, right? The content of a will be transferred to this register r1, that is the meaning. Okay, so after that add r1 comma b, right? So the memory operand at address b will be added with register r1 and the result will be stored into the same register r1, right? So the meaning is the value of b. Okay, the content of b, either it may be numbers, fraction number, integer number, anything. Okay, it will be added with register value. Okay, this register value consists of the memory of memory address of a value. Okay, so finally we get a plus b value. So the result a plus b is stored into the same register r1. This is the explanation of this micro operation. After that, the move micro operation. So what is the use of this move micro operation is it is the transfer. Okay, or move one space to another one memory space. Okay, r2 comma c. So the meaning is the content of c. Okay, take the second element only, not the first element. The content of c will be transferred to the register r2, that is the meaning. So the micro operations are memory operand at c will be transferred to the register R2. So that is the meaning. After that, mul R1 comma, sorry, one more thing, add R1 comma D. Okay, here the register, add R2 comma D. Here the register R2. Okay, the content of register R2 will be added with memory operand at address D, the content of or value of the D. Okay, then the result will be stored into the same memory R2. Okay, after that the multiplication operation, instead of um, instruction mul, okay, a subroutine mul, r1 comma r2. So the find the product of these two registers, that is r1 star r2, and the answer will be stored into the same register r1. After that move, okay, so this move operation is used to transfer the value from the register to operands. Okay, so this register contains the final answer. This final answer will be moved to the operand or variable. Okay, that is the meaning. So the micro operations are memory operand at address x is equal to register r1. Okay, so it contains the above operation. After that, advantages, they allow more complex operations and can be more efficient than one address instruction, since they allow for two operands to be proposed to be processed in the single instruction. They also allow for a wide range of addressing modes. Then disadvantages, they require more memory space than one address instruction and can be slower to execute, since they require operand fetching and addressing. So fetching is nothing but holding the address of the next instruction. So the program counter holds the address of the next instruction to be fetched. So while running the program, the first instruction is going to executing. Okay, the program counter starts withholds some another instruction set. Okay, whenever the cpu need a instruction to be executing, the program counter give the instruction from the memory to the cpu, and executing this operation we get the final answer. So each type of micro operation we want a program counter, accumulator register, cpu memory registers, etc. So this is the disadvantages. Okay, this is the main disadvantages of these things. After that, three address instructions. This has three address field to specify a register memory location. A program created are much short in size, but number of bits per instruction increase. So the meaning is the three address instruction field specify a register memory location. Okay, it going to allocating the memories, like r1 r2 into the memory units. Okay, it may be a same memory location. Okay, or it may not same memory location, that is not a problem. But the value of a product or addition value, we going to store the variables, sorry, store the data, and retrieving the data from that memory location in same manner. Okay, program created are much short size in size, but not short in size, but number of bits per instruction is increase. So no need to bother about the size, but the number of bit per instruction it will be increased. Okay, so this is the main problem. When the program counter starts the base register, the flags will be started. Okay, each and every time the flags counting. So these kind of drawbacks are available in three address instructions. After that, three instructions. These instructions make creation of a program much easier, but it does not mean that program will be run much faster much faster, because now instruction only contain more information, but each micro operation, changing content of register, loading address in address bus, etc., will be performed in one cycle only. So following the same instruction, x is equal to a plus b star c plus d, we followed r1 and r2 are the base register in the accumulator register, sorry, index registers. Okay. So memory of x, so here the memory of x is denoted to the same memory location or different kind of memory locations from the CPU. The opcode field, the instruction format. In this instruction format have the five field. The first one is same opcode field. Opcode is nothing but it is the operation code. Okay. The operation code is minus plus star slash like that. Then source address. This type of source address contains two portion. The first segment is source address 1, that is register 1. The second segment is source address 2, that is register 2. Then destination address. So destination address is the another one register. The use of this destination address is to store the output value or result value to the memories. Okay. After that, mode field. This mode field is used to manage the operation to be performed, right? Then r1 is equal to memory operand at address a plus memory operand at address b. Okay, the meaning is the content of operand A will be added with the content of operand B, then the result will be transferred to the register R1. Okay, so that the micro operations are add R1 comma A comma B. So this is the meaning. The second subroutine says add R2 comma C comma D. The R2 is memory operand at address C will be added with memory operand at address D. Um, the meaning is content of operand C will be added with content of operand D. Then the final answer will be transferred to the register R2. Right? This is the meaning. Then multiplication operation. So instead of mul, x comma r1 comma r2. Okay, so this r1 consists of a value of a plus b, this r2 consists of the value of c plus d. We going to find the product of these two elements, we get the expression value. So m of x is equal to r1 star r2, right? So the micro operation says to be the content of register r1 will be multiplied with content of register R2, and the result will be stored to the memory operand at address X. So why we are putting X here is from the question itself they given X is equal to some expressions. Okay, so only we put the same opcode value or same opcode variables here also. Okay. Three address instructions. The advantages, they allow for even complex operations and can be more efficient than two addresses. Instructions since they allow for three operands to be processed in a single instruction. They also for wide range of addressing modes. Disadvantages, they require more one memory space than two addresses instructions and can be slower to execute since they required operand fetching and addressing. So the meaning is, so the meaning of the disadvantages. Okay. uh, so so far we discussed about the memory consist of a stack register, accumulator register, base register, some of the CPU registers, like that. But here we going to occupy the more number of register. Okay. uh, so we going to use a two type of source register, and we use another one destination register. These two type of source registers contains the some temporary memory storage for carried out the carry in between the steps, in between the steps of calculation while addition, multiplication, subtraction and division. Okay. uh, the overflows, the overflow, what do you mean by overflow and what do you mean by underflow? We want to add a two element. Okay. We want to add a two digit number. Okay. Like 5 comma 5. Consider 5 is a one element, another one 5 is the another one element. We want to add these two elements. The output will be a two digit number, right? The inputs are one digit number, then the output is two digit number. So here one overflow is occurred, right? So this kind of overflow will be stored into the some other memory locations, some other temporary storage locations, that is called accumulator registers. Okay. uh, so this three address instructions field occupies more accumulator registers or more memory spaces. So this is the main drawbacks, right? So this is one of the disadvantages. Okay. Now we're going to now we have a end of the session. So we're going to summarize from the beginning. Okay. All of you listen carefully. Okay. Go to the slide. Program counter. Program counter is nothing but it is a register. It is a CPU register. It is used to fetch the next instruction, fetch the address, and it holds the address. Okay, program counter fetch and holds the address of a next instruction, right? I give one example. If your program contains 10 step of instructions, okay, each and every one instruction contains some address, some memory spaces, some opcode field, some mode field. Okay. Then the program counter starts at the zeroth value from the first instruction. It holds the first instruction. While CPU going to run a program, the program counter give the first instruction to the CPU register. Okay. After that, this program counter starts with the address of the next instruction, and it fetch to this instruction to executing the CPUs and the next time or next instruction. Okay. Likewise, the each and every instruction going to performed. Clear about it? Then accumulator register. So what do you mean by accumulator register? Already we discussed about accumulator register, uh, base register, key register, index register, some other registers, temporary registers, direct registers, indirect registers. So these are all the flag registers. These are all some accumulator registers. Okay, each accumulator register contains some inputs, some mode field, some operations, or it may be some other empty memory spaces. Okay, this kind of empty memory spaces we allocating from CPU for the purpose is in addition we have overflow. Okay, so the overflow may occur the addition of the two operations or product of the two operation, sorry, product of the two operand value, and the addition of the two operand value we get the overflow, right? um, the overflow is nothing but adding a to one digit number we get the two digit number in output, that is the overflow. The underflow is nothing but subtracting or dividing a two operand, we get the uh, simplification of the digits. Okay, for example 20 is the input, we divide the 20 by 2, sorry, 20 divided by 5, so the final answer is 4. The 4 is the underflow, right? So underflow is the takes place in the subtraction operation. So these kind of intermediate values, these kind of carries, okay, uh, are we going to divide an element. Okay, each and every step we have a quotient and remainder, right? You want to go if you want to do the division operation in your computer system using this assembly level language program, so each and every step we have the quotient value and remainder value, right? This kind of quotient value and remainder value will be stored in this accumulator memory only, right? So all of you know now know about the importance of the accumulator memory, accumulator register. Okay, then base register. Okay, the base register content is added to the addressing field of instruction to obtain to the effective address. A base register holds the base address. Okay, it holds the base address and addressing field of instructions. It gives the displacement according to the base address. A particular register has to be selected from the register set according to the instruction. Then stack pointer. So what do you mean by stack? Stack is a data structure. It is used to store the data into the memory. Um, so in the stack operation, we just do two operation, push and pop. Okay, the push is nothing but it is going to use the insert a new element from the stack. So here read the new values, read the new operand opcode values to the computer memory. So that is the main value of stack pointer. Then pop operation. Okay, so it is the value, it is the operation of push operation. So the pop operation, see the diagram. So pop operation is used to delete the element from the stack. Okay, so the arrow is like inserting, the arrow is like deleting. Okay, so insert a new element is takes place top of the stack. So deleting a new element, so deleting a already added element from the top of the stack. Okay, that is pop operation. The stack contains push and pop operations. The push operation takes place at the empty stack, okay, or empty memory location only. The pop operation takes place at the full stack, okay, full memory location only. The empty stack, uh, sorry, the full stack cannot do the push operation. Okay, whereas in empty stack we cannot do the pop operation. Instruction formats, there are three kinds of there are four kind of instruction formats is available. Three address instruction format and true address instruction format, and one address instruction format and zero address instruction format. The three address instruction, we know that we have three variables, three opcode and the operand fields to be to find the value of a given expression or find the product of the variables or operands or opcode values. So this is the meaning. Then two address instructions. These two address instruction, we know that it contains only two memory fields. If you want to need a more memory, it can occupy from the CPU memory, that is accumulator register. Okay, one address instruction. So this one address instruction having only one opcode. Okay, only one opcode field to be fetched. So remaining opcode fields are occupied from the accumulator only. Okay, so only we using uh, store, load, these kind of accumulator instruction fields. Zero address instruction. So we already discussed about zero address instruction. There is no need to use of stack, sorry, no need to use of accumulator register, base register, index register, program counter, etc. So here we using only a stack memory. Okay, for doing this operation we use the stack memory only, stack memory and stack operations only, right? Then advantages and disadvantages we already discussed, right? So after that, assembly level language program, for a given instruction. So this is the assembly level language program, or it can be said to be a subroutine of a addition of the following expression. Okay, so I already explained about it in detail to you. This is the another one, instruction format, last one. So this is also one of the three address instruction formats. Okay, so disadvantages and disadvantages we already discussed. So finally, end of the session. So myself, I am Mohammed Hassan, assistant professor. Okay, if you have any feedbacks or comments, you just give a feedback or comments in the below session. Thank you.